Hey everybody, in today's video we're going to be discussing some segment relationships in circles. So secant segments, external secant segment, and tangent segment. So the first theorem is when you have two chords that are intersecting inside of a circle. If two chords intersect in the circle, then the product of the lengths of the segments of the chord are equal. So what that means is you take each segment, so take segment CD and break it into the two parts, CE and ED, and multiply those two parts together, and then take your other chord, AB, and break it into the two parts, AE and EB, and multiply those two together. Those products will be equal to each other. So AE times EB equals CE times ED. So here's what it looks like in an example. So we have two chords intersecting inside of this circle. FE is intersecting GE. So now if we take the parts of the chord and multiply them together, so 7 times 10 should be equal to X times 14. So when we multiply, 10 times 7 is 70, and then divide by 14, and you get X is equal to 5. Now we want to find the length of each chord. So the first chord, FE, we just add 7 plus 10, we get 17. And now that we know X is 5, 14 plus 5 is 19. So those are the lengths of our two chords. All right, a secant segment is a segment of a secant with at least one endpoint on the circle. An external secant segment is a secant segment that lies in the exterior of the circle with one endpoint on the circle. So PM, NM, KM, and JM are secant segments of circle Q. And then NM and JM are the external secant segments. So in this next theorem, we're going to be using those two vocabulary words. So if two secants intersect in the exterior of a circle, then the product of the lengths of the secant segments and its external segment equals the product of the length of the other secant segment and its external segment. So the good way to remember this is whole times outside equals whole times outside. So what that means is if we look at the two secants, so that would be AE times the outside BE, so that's whole AE times outside BE equals whole CE times outside DE. So let's take a look at what this looks like. So in this, we have two secant lines intersecting on the exterior. So we're going to do whole times outside equals whole times outside. So the whole part of DE, that means 9 plus 7, which is 16, times the outside part, which is 7. So we're going to do 16 times 7 equals whole, which is X plus 8, times outside, which is 8. So that would look like this. Whole times outside equals whole times outside. Then we're going to simplify this. 16 times 7 is 12. 8 we're going to distribute in, we get 64 plus 8x. Subtract 64 from both sides, we get 48 equals 8x, and then divide both sides by 8, and you get x is 6. They want the length of each secant segment. So DE, that's going to be 9 plus 7, which is 16. And then GE, now that we know x is 6, it's going to be 8 plus 6, and that gives us 14. All right, and then our final theorem is, that we're going to get to involves tangents. So a tangent segment is a segment of a tangent with one endpoint on the circle. So AB and AC are both tangent segments. So here's the theorem for when a tangent line intersects a secant line. So if a secant and a tangent line intersect in the exterior of a circle, the product of the lengths of the secant segment and external segment equal the length of the tangent segment squared. So we're going to do just like we did in the previous theorem, where we do whole times outside for the secant line, but then it's going to equal the tangent line squared, which is technically still whole times outside because the entire tangent line is on the outside. So it is the whole times the outside. So it's really not a different theorem, but I guess it looks a little bit different because we're just squaring the one segment. So that would be AC times BC equals DC squared. All right, so here's an example of that. Let's do the secant times the external secant. So that would be 20 times 5 equals x squared. So 20 times 5 is 100. So 100 equals x squared. And then to get rid of the x squared, we do the square root. So we get x is equal to plus or minus 10, but the value must be 10 because it represents length. We can't have negative 10 as our length. So x is equal to 10. All right, so that's all we have for this lesson. If you have any questions, let us know. Have a good day.